Our next speaker is Drew Atkins. He has over 20 years of experience in financial services and consulting. His strengths include object-oriented software development, use case analysis, financial reporting systems, profit and loss reporting, and project management. As Jonah Group's financial officer, Drew is responsible for the financial stewardship of the company, including the capital and operating budgets, financial affairs, and treasury management. Jonah has a special importance for AI Geeks, as they generously accepted to host our very first meeting more than 2 years ago. At that time, we were very proud that we had over 100 members. They offer us some nice food and also wine, so I don't think anybody remembers what we talked about at that meeting. Drew will talk to us about use cases for using blockchain and AI technology. They range from mundane data sharing use cases to esoteric use cases like autonomous intelligence agents that own stuff and can't be turned off. Let's invite Drew on the stage.
Good evening, everybody. I'd like to thank Inmar and Gracelyn for a couple of great presentations. Hopefully mine will be somewhat as interesting. I'm going to talk tonight about artificial intelligence and blockchain. So first, full disclosure, I'm not really an AI guy, I'm a blockchain guy. But through our blockchain practice, we have found several use cases where these two technologies can be used together, and of course the ensuing hype is in hyperbole. A couple of the projects we've worked on, Ferrum is a company that has is putting the leasing information onto the blockchain in order to reduce the turnaround time from weeks down to hours. And the Royalty Exchange is a company who's fractionalizing contracts around the mine financing into smaller pieces and trading them on a crypto exchange we developed for them that allow them to, essentially for mere mortals, people who don't have $50 million to participate in this particular market. I'd like to start off initially by talking a little bit about some of the history of artificial intelligence because it reveals a couple of points where we are able to mirror it with blockchain technology. And really this practice starts back in the 1950s with Alan Turing, who created a mathematical model for how machines could think. His idea was that instead of trying to simulate an adult brain, let's simulate a child brain and have it evolve into or grow into an adult brain. And so this is really the first idea that machines could learn themselves. Back in the 50s, Werner also worked on cybernetics, which led to the field of artificial general intelligence, which is a field where AIs can deal with unpredictable situations. And this is particularly applicable for some of the use cases we have later on in the combination with blockchain. I'm not going to go through all these stages in detail, but I do want to talk a little bit about a shift that occurred in the late 1990s, where in the 1990s people were still working on creating better AI learning algorithms, ways for machines to that were more sophisticated. And this cost a lot of money and took a lot of smart people a lot of time to do. Then in the early 2000s, a paper was published out of Microsoft with Banco and Brill that really started this change in emphasis in the way we train machines to think. They were trying to create a better spelling checker. In order to do that, you have to disambiguate words like two, and two. All those words could be spelled correctly, but depending on the context they're used in, they might not be the correct spelling of the word. So they started off like everybody else trying to create a better algorithm, something tailored specifically for this use case in order to solve the problem. But they quickly ran out of time, resources, and money in order to do that. So instead they decided to take a different approach. Instead of doing the hard work of trying to create better machine learning algorithms, they decided instead to try and throw more data at the problem. And they found a very interesting thing. So along the x-axis here, we have the size of the training data set, and along the vertical axis, the resulting accuracy. So each of the lines on the chart represents a different machine learning algorithm, and the red line really represents one of the state-of-the-art algorithms at the time, a memory-based technique. And for low volumes of training data, we see that the more sophisticated algorithm performs better. But for large data sets increasing by 3 orders of magnitude, we find that even perceptrons, which is an algorithm dating back to the 1950s, actually outperform the more sophisticated modern algorithm. So suddenly the emphasis switched from trying to create better learning algorithms to spending more time curating and honing the data sets, collecting large data sets in order to train better AI models. In about 2007, Google published a paper on the unreasonable effectiveness of data, and this really kicked off the race to collect large data sets. And companies like Google and Facebook, they really have formed what we call these data moats around their data assets. In other words, it's very hard for a competitor to come out and create better AI in the search space than Google because they have so much data, they can train their AI modules better, and as a result, it makes it very difficult for a competitor to come and break into that market. So there's this sort of hoarding mentality that comes with these large data sets companies have collected. And I'm going to talk a little bit more about why that might not be a good thing in just a minute. The first thing I'd like to talk a little bit about some blockchain characteristics and some areas where they might be useful with artificial intelligence. So first off, blockchains are decentralized, so this can help with data sharing. They're immutable, which makes them good for audit control and perception building or reputation building. And finally, tokenization allows them to be traded on electronic exchanges, and we'll talk a little bit more about each of those in a minute. But by traditional standards, blockchains are terrible. There's lots of latency, they're very slow, they take all kinds of compute power, and they use all kinds of energy. So we need different blockchain technologies that allow us to go at web scale, to store large amounts of data, and to find things quickly and easily. And we'll talk about some of those technologies in a minute. So these are the 4 use cases I'm going to talk about today, and as Dragos mentioned, they go from being very mundane data sharing type use cases to artificially intelligent distributed autonomous organizations, which is kind of robots rule the planet kind of territory. I think after hearing Graceland's presentation and the question she got, I think I might add a 5th one, which is self-sovereign identities and how they might play a role in the data. So maybe the next presentation I'll include that. So if a credit card company is trying to create a better fraud detection algorithm, and they only run it on their own data set, they're not going to see instances of fraud that their competitors might have seen that hadn't happened in their organization yet. Now, if all the credit card companies get together and share all that data, we can create one super AI module that can be shared by all the credit card companies, and they all benefit from better fraud detection. But there's this tension between the hoarding and sharing. So the sharing benefit really has to outweigh the hoarding benefit in order for a company to do this. And blockchain can help here because in a blockchain system, no one central organization owns the data. And this was a big problem in the music licensing industry where nobody could really agree on who would own the repository for the music licenses. So what ended up happening is that you go license a tune on iTunes and you can't play the same recording on Spotify because the licenses aren't compatible between the platforms. So what are some of the technologies that can help here? There's a platform or a protocol called IPFS, which is the Interplanetary File System. Why be global when you can be interplanetary? But it's really a way that it sort of works like an Airbnb for your spare disk capacity. So if you have a computer sitting at home with some spare disk capacity connected to the internet, you can rent out that spare disk capacity to somebody who needs to store data, and you earn Filecoin in exchange for storing that data. It also uses a consensus mechanism. I'm not going to go into too many of the details of the blockchain technology, but it uses a consensus mechanism that is much more lightweight, what's called proof of storage, whereas Bitcoin and Ethereum use a proof of work consensus algorithm, and that's what really uses up all the computing power and energy to process those networks. So IPFS provides a much lower cost way of storing large chunks of data. For example, to put a gigabyte of data onto the Ethereum network costs in the millions of dollars. Obviously, it's just not going to fly for most applications. IPFS also was trying to be a replacement for the World Wide Web, and obviously it's not there yet, but the World Wide Web has many single points of failure. So, for example, during the Arab Spring, Egyptian people woke up one morning to find that their internet access had been cut off because of these single points of failure. IPFS is truly a distributed system. If you publish something there, as long as the miners on the planet are making money from mining that system, that object will be there indefinitely, and it's very difficult for any single organization or any single entity to then shut down access to the data. The second technology I'd like to talk about is the interplanetary database. There's sort of a theme here. But it essentially allows us to put data into a blockchain and then be able to query that data and find things in the, just like you can with any database, but traditional blockchains do not allow good query utilities. So we'll talk a bit more in a minute about how all these technologies can work together. I'd like to introduce the second use case here, which is the audit trail use case. If we're going, the market right now for curating and publishing data sets is in the billions of dollars, and if we're going to continue that industry and also grow an industry around well-trained models, we need some way to track the provenance and essentially the reputation of these data objects. And blockchain is a great place to put this because of the immutability aspects and also the digital ownership aspects. So if a third party, a government authority, or an auditor comes out and attests to the validity of the data at a particular point in time and encodes that hash code with their digital signature, that's available for anybody to check at any point in time, and this builds reputation for the underlying data objects. But we not only can track the reputation of the data, we can track the provenance of the model building. So there's technologies like Intel's trusted computing platform, which guarantees that a particular piece of code ran on a particular processor, and this was the result that came out of that computation. And so by using these tools, as well as putting out the results of the training process, we can know the provenance not only of where the data came from and the data was correctly captured and labeled, but also that the model was correctly trained and wasn't tampered with. So how might this all work together? The first thing we need is we need a set of data stores, and I proposed IPFS and Filecoin as two potential places. We could also publish these objects through traditional web services, but those web services only will tend to last as long as the organization that supports them. Whereas with IPFS, we have a global community of people who are dedicated to trying to make money off making those objects always available. We can layer on top of that the interplanetary database and put pointers into the IPDB along with attributes of these underlying data objects and models so that we can now find these objects quickly and efficiently. So how might we use this structure? Somebody might want to come along and find some data that's applicable to their business domain. They could go and license that data, then use it to train the model and test the model, and finally publish the model. Now, in the publishing step, the first thing is to write it out to a globally available data store, like Filecoin in this case. And then at the end of the blockchain, we would write out the pointer to that object along with the attributes of the object. So now other people can find that object and understand the business domain and the geographic area or whatever else the attributes are that distinguish that particular model. Third parties can come along and certify that model, and this might be auditors, this might be government authorities, and then finally, people can come along and look at those attestations, find the objects that might be applicable to their particular business domain that they need to use in their own operations, and then license the use of that particular model. These steps at the beginning and end, these licensing steps are really intended to be exchanges of value. And so this is another thing that we can write out to the blockchain. On the one side, we likely have cryptocurrency that's being paid for that license. And on the other side, the copyright holder would write the license out onto the blockchain as the two sides of that transaction, which means that the person who has the license can now prove to anybody on the planet that they have the right to use these objects for their intended purpose. The third use case, I'm not going to talk about in too much depth, but if we can tokenize these assets, essentially put a hash into a token, and then cryptographically sign them, we can trade these tokens now on a electronic data exchange. And there's many crypto exchanges that are out there today with underlying blockchain technology that can be used to make these trades. This is very similar to the way securities are traded on electronic exchanges today. And just like we have AI modules or AI algorithms that are trading financial securities, it's likely in the future we'll have AI algorithms trading other AI algorithms on these markets. So we could imagine a case where this sort of brings us to the capability of an AI module to enhance itself. So it can go out and find additional capability on these markets. And the example here is a document analysis agent, perhaps for the legal community, where it might be looking for precedent, it might be looking for evidence in these documents. Most legal cases today have tens of thousands of pages of documentation, and humans are very bad at scanning that much data. So now if the document analysis agent encounters a particular business domain or a diagram type that it doesn't understand, it can go out to the market, it can find agents that are able to do that analysis for it, add it into its own analysis, and then return the bundle back to the lawyer who initially commissioned the work. On the right side here, I have the third party, in this case the lawyer, who would pay the document analysis agent in cryptocurrency, and then a subset of that amount could be paid out to each of the agents that was hired to do that analysis. So this is a way that these AI agents can actually grow and connect themselves together using these crypto exchanges. The final use case I'd like to talk about today are artificially intelligent distributed organizations. And it's a real mouthful. It's also the villain in many sci-fi movies. You can think The Matrix or Skynet. But essentially, these are AI agents that own stuff and can't be shut off. So the distribution, the decentralized aspects of blockchain give the can't be shut off part, because you have to shut down the entire network of a bunch of independent operators in order to turn them off. And secondly, the cryptographic signatures that are written onto the blockchain allow a set of key value pairs to be created for that agent, and then that AI module can then actually own stuff that's written out to the blockchain. And this could be cryptocurrency, or it could be tokens for digital assets, or tokens for assets in the real world. The AI part of it adds the decision-making capability into these ADO organizations. And in this case, the field of artificial general intelligence is probably the most applicable. So what are DAOs? So today, really what DAOs are is they're Solidity scripts, the underlying programming language of the Ethereum network, running on the Ethereum network itself. And so Ethereum tries to be a world computer. Essentially, it's a bunch of miners all over the planet running programs that are put onto the Ethereum network. It has an underlying cryptocurrency named Ether as well, but it's essentially trying to be, and the programs and the output of the programs are all written onto the blockchain. So there's agreement amongst all these nodes about the current state of this world computer, of this machine. The decisions for the organization are written into the lines of code in the Solidity scripts, and these dictate what the organization will do and what decisions it will take. You know, computer viruses are an example we've probably all encountered of a distributed autonomous organization. Hopefully we'll create some that do better things than what viruses do, but this is kind of the early vestige of a DAO. There was one in particular DAO, and it's an interesting story. So the DAO was the very first distributed autonomous organization, and it was a Solidity script that was run on the Ethereum network. It was set up to be an investor-directed venture capital fund. So people all over the planet put money into this DAO. The DAO owned it through its own set of public-private key pairs, and then people would all vote on what crypto investments that DAO should make. The DAO then had all the program in it to go out and purchase those crypto investments on behalf of the investors and then pay the returns back to the people who'd invested. Now, unfortunately, there was a bug in the script, so it was launched in 2016 and with $150 million worth of Ether, and it was instantly drained of about $50 million because there was a bug in the script. And this brings up a very interesting point. If you put a program onto an immutable platform, there's no version 2. It's going to run forever, and you can't make changes to it. So the whole testing debug cycle is very different when you're deploying things on blockchain than it is on other types of computing resources. It gets even weirder though, because what ends up happening is all the miners have a big conference on the Ethereum network, and they get together and they say, well, we can't allow this to stand. We can't allow this $50 million to have been drained out of this corporation or this DAO. And so they decide to roll the whole blockchain back to before the DAO was actually published on the blockchain. And at that point, and then start to roll it forward again. So essentially all the $50 million, the whole $150 million is now returned to the original investors. But then there's a group of miners who say, no, once it's written to the blockchain, you can never change something. And they still mine the sort of the Ethereum Classic, and the rest of most of the world mines on the Ethereum New chain. So it's essentially a Y, this fork in the blockchain. And the weird thing is all the ether that sat in that original stem of the Y now exists in both versions of the chain. So it's very unclear what all that means exactly. And that's really the point of this. This is really the Wild West, and there's no legal protection. So if you write a DAO and you put it out onto a network and it does something nefarious, you're probably legally liable. There's no protection like there is for traditional corporations with DAOs. Now there are a number of companies out there who are building better stacks for developing these things in a much more safe and a much more robust way, but these are all evolving technologies right now. So in the field of AGI, generally, these are feedback systems of some sort. So there's a controller that issues commands, and then we observe the changes in the state, and then we figure out what we should do next. If we take a module like this and run it on a world computer like Ethereum, then we essentially have an AI DAO. So what could some of these AI DAOs do? We could imagine an art DAO, and this might go out and create some digital art, sell it, earn some cryptocurrency for selling that art, and then it might go and hire a bunch of robot actors to act out the plays around Isaac Asimov's Stories I, Robot, and then maybe AIs would come to ponder the paradoxes of that production. We could imagine self-driving, self-owning cars. So a car could go out and provide rides for people. People would pay it cryptocurrency. And then when it needed repair, it could go and spend some of that cryptocurrency in order to get itself repaired. And these DAOs continue to exist as long as they can earn enough to not only run themselves and pay for themselves, but also pay for the computing power on the world computer, which does not cost an insignificant amount of money. So as long as there's enough resources being generated, there's no reason why these programs could not continue to run. Essentially any DAO with AI infused. So instead of having the investors in the DAO case decide what to invest in, if there was an AI module that made decisions about those investments, then essentially we'd have an AI DAO, or any existing software as a service application if it was moved to decentralized infrastructure so it doesn't go away when the underlying organization goes away, and also has additional automation added to it and decision-making capability. So just in summary, AI needs big data, and blockchain can help organize and share that data. AI needs reputation, and blockchain provides a way to store that reputation. Blockchain can be used to trade AI algorithms, and finally, blockchain adds assets to AI so that AI DAOs can go out and rule the planet. I put together a list of a bunch of companies. I will publish the slides that I'm not going to go into these in detail, but these are all people who are working in this space, this sort of amalgamation of AI and blockchain. So thank you very much for listening.
I'm thankful for the very wonderful talk that you gave on blockchain and AI. My question is specific to DAOs.
Yep.
So do you think at one point DAOs will have to stretch, let's say, multiple blockchains, for example, Ethereum, Bitcoin, altcoins together?
You know, this is a big issue in the blockchain world right now, this interoperability aspect where we have a bunch of sort of isolated chains that all exist today, and there's no real way to communicate between them. I think what's going to happen is we're going to find that chains will evolve for specific industries where if a bunch of the banks decide that this blockchain that does overnight bank settlement is useful to their operations, they're going to dedicate mining resources to that chain, and that chain will flourish. And so I think we're going to see over time that there's going to be kind of a shaking out of some of these early blockchains. And it's not clear right now which ones are going to rise to the surface and exist in the future. There are companies also working in the interoperability space. So ION, for example, has their own blockchain, which of course just adds to the problem. But they're building adapters between their blockchain and all the other blockchains like Bitcoin and Ethereum, for example. And to some extent, it's had some success, although it's still very early days on the interoperability question.
in the back.
Hi, I'd like to start my question by asking you a question if you've heard of the McKinsey's 3 Horizons model.
I don't know the McKinsey's 3 Horizon model, no.
Okay, so it's a model that essentially explains that in corporates, they have different levels of innovation that they're willing to take on. And very light innovation would be in the first horizon very soon. Second horizon would maybe be 3 to 5 years. And the third horizon will be further.
Okay.
And so my question is, these topics of AI, DAOs, their use cases are extremely innovative, we could say, and a bit far off. So my question is, how will these actually be applied into corporations, and how long do you think that will be? And then in the meantime, the people that are working on these technologies, how do they essentially profit from these technologies? Or is it that the profit will not come from these for quite some time?
So I think that there are a bunch of use cases for, that underlie the sort of blockchain usefulness. And as I mentioned, the sort of overnight interbank settlement use case is a big one. But for using DAOs, it's really not clear that they're much beyond speculation at this point. And so the time horizon, it's really unclear how soon these will be adopted or turning profits for people. I think that today they're really deployed as experiments. And the people who, for example, put $150 million into the DAO were just enthusiasts and probably people who had earned or had a big windfall by being early investors into Ether. So I don't think there's anybody really seriously using these technologies in a corporate environment or in a money-making environment today. There's much simpler use cases where blockchain technology is being used. For instance, the international payments, the overnight bank settlements, self-sovereign identities. These are all valid use cases that are applicable today, and people are starting to apply them, especially in the medical field. But for DAOs and the combination with AI technology, it's still all very speculative.
I have a question. One is to do with law and the other is culture. You mentioned the 50 million disappearing. In this world of blockchain and Bitcoin and so on, has the law and case law caught up? And the second question is, what is the culture and the code of conduct of the players in this world?
Okay, so first off, there's definitely a lot of dark money that trades on through blockchains, through Bitcoin and through Ethereum. There's no question about that. The legal community has not really caught up. There's a bunch of legal firms in Toronto who are currently working on what case law might look like around blockchain. But in that one particular case I talked about where the $50 million had been drained, there is very little recourse. It's not like there's a central body you can go to petition to say that my money was stolen. And so this is one of the benefits and also one of the drawbacks to blockchain technology. And as it stands today, it's not clear where the law is going to fall. Some countries classify Bitcoin as a currency, some classify it as an asset, and so there's very little agreement right now on how these things are even classified, let alone how they fit into any sort of legal structure.
Just a quick question over here. I like the example of the DAOs taking over certain aspects of banking, like overnight banking. But I was having trouble understanding that when you have something that's a DAO that is operating autonomously, that's decentralized, how do the banks, and this is a bit of an amateur question on my part, how do the banks know that this DAO that they launched to take over this service actually is ending up earning revenue for them and doesn't turn into an autonomous competitor almost for their services at some point? So the banks will control that particular operation very carefully, and that will be a private network, it's most likely. So there's two different types of blockchains. There's public blockchains like Bitcoin and Ethernet, where anybody's invited to play and anybody who wants to write a program or buy the currency can. There's other blockchain networks where there's a group of people who have a common interest, like the banks,
in making sure that they have their overnight settlements all in place, will create their own blockchain that is only operated by them. So each bank in that exchange mechanism would own a node on the network, and they would exchange information through that network. It wouldn't be open to the general public, and it would be a protected and permissioned network. So the banks, and in that case, it's probably not a DAO example. It's probably just a fundamental blockchain solution to that particular problem. We don't need to layer on this sort of autonomous code running on an Ethereum type of network.
Couple of more questions for ladies. So men, put your hands down. Okay, there. Always have the men coming first.
So at the bank, sometimes we have like teams working on certain models, and then they pass on their models to different applications, and they can't track like the use of their model. And you said that blockchain can be used for model governance. So then how can you actually track whether or not it's used unethically?
So I don't know that you can track that it's being used unethically. I think that you can track the sort of provenance of the development of the model and verify that it was constructed in a well understood and a proper manner, and that the testing was done correctly, that the data sources were attested to by somebody who understood the data set at some point. I think those things are what you can track today on the blockchain. Blockchains don't really care about ethics in particular, but one thing you can do, as I was saying, if you write a license onto the blockchain, then you could challenge somebody who's using a model, perhaps in a way it's not supposed to be used, to say, do you have a license, or have you contacted the owner of the copyright and gotten permission to use this model or this piece of data for this purpose? And so that might be a way that it could allow people to at least challenge the use of the model.
Okay, thank you very much, Drew.
All right, thank you, everybody.